In this video, we are going to be introducing direct and joint variation and how you go about solving them. So the idea of a direct variation is basically as one thing increases, it causes another thing to increase. So the more hours you work, the more money you should get paid if you're getting paid hourly. Here's kind of a situation, and if I have a direct variation, I can always use proportions to solve this. So it says find the cost of 10 apples if 4 apples cost $1. So the more apples you buy, the more money this should cost. So I can create a proportion out of this. So find the cost, which we don't know, for 10 apples. So this is a cost. These are your apples, and I just want to be consistent with it. So then if 4 apples costs $1, how much is it going to cost? So I cross multiply to solve. That's the nice thing about setting up proportions. I already have a method for it, and that is me cross multiplying. So 4 times x is 4x equals this cross product, which is 1 times 10, which is 10. Divide by 4, divide by 4. X is going to equal 10 divided by 4, which is $2.50, so $2.50. Okay, so that's one way to do it. There's absolutely more than one way to do this, but that's kind of we're shooting for, at least on these couple of examples. You can use a proportion to set things up. So how many apples can be purchased for $10? So I can set the whole same thing up. That let's see. So we had a price, which this time we know, but we don't know the number of apples, would still equal $1 for every 4 apples. And then we cross multiply. So we multiply this, and that's going to get us an x. And that cross product is going to be a 4 times 10, which is 40. So how many apples could we buy? We could buy 40 apples. All right. Different situation is, let's say we have a truck travels 102 miles on 6 gallons of gas. How far will it travel on 30 gallons of gas? So 102 miles and 6 gallons. And then that's going to equal how far? We don't know, miles in 30 gallons. All right. There is a shortcut to this, especially if I can see how this thing relates to each other. To get from 6 gallons to 30 gallons, I would multiply by 5. So I could actually just multiply that by 5, and that's going to give me my miles. Okay, if you're not comfortable with that, totally good. We'll cross multiply. So I think that's 510 if you multiply that. But if we cross multiply, we have 6 times x would equal 30 times 102. So 30 times 102, which would be 3060. Divide by your 6. X would be 510. And our label that we didn't know was miles. Okay, so that shortcut works. If we know that to get from this denominator to this denominator, it's by multiplying by 5. So if we kept everything proportional, you could also multiply the top by 5. And 5 times 102 would get you your 510. All right. So a couple others. So here's a little bit of a different approach to it. There is a more mathematical equation kind of style to this. So there is an equation for a direct variation, and it looks like this. Y equals k times x. And this k is known as a constant of variation. Okay, I like to kind of call it a rate. That's really what it is. It's like a linear equation and has a slope. So that slope is your rate. So, so instead of setting up a proportion, because they may ask for this constant rate, this constant of variation, it might be a question. So that means that they're going to give you enough information. Basically, they're going to give you an x and a y so you can figure out what the k is. Okay, so if they're asking for that constant of variation, it's because they gave you an x and a y. So how do you find it? You're going to sub in x and y, then solve for k. Okay. So if you have a 15-ounce box of cereal, costs $2.29. So you have a 15-ounce box is costing you $2.29. So there's your x, there's your y. Find the constant of direct variation to the nearest 10,000ths of a dollar. Okay, so here's that rate field, cost per ounce kind of a thing. So we have our y value. So if our equation is y equals kx, our y value was $2.29, and our x was for 15 ounces. Divide by 15, get k by itself, throw that in the calculator. We get a k value of not a lot, but a lot of decimals. 3.29 divided by 15. Okay, they wanted to go to the nearest 10,000th. So 10,000th is tenths, hundredths, thousandths, 10,000ths. Okay, so that 6 is going to bump that 6 up to a 7. So we're looking at 0.1527. So that is our K. So that is actually a cost per ounce. So your cost per ounce equals the lower 15 cents. Okay. All right, so let's go to a different one. So we have an architect's drawing has been scaled so that every quarter of an inch on the picture is equivalent to 5 feet. Find the actual measurements of the following things. So if you were to measure 0.75 inches, and some of you are totally going to be comfortable with, for every quarter of an inch is 5 feet. So if it's 0.75, it's 3 quarters. So then you multiply that by 3 and get 15. If you're not comfortable with that, that's okay. Here's kind of the long mathematical way to do this, because sometimes you can't always mentally do it. So our equation is y equals kx. Your y value, well, this is your x, this is your y. You would plug in your y value of 5, your k we don't know, and your x value is 0.25. Divide that over. Show my work. 0.25. 0.25. All right. So if you divide that, 5 divided by 0.25, you get an answer of 20. So what that represents is 20 feet per inch is what you got going on. That's your rate. So that means that this is your actual equation. You found your slope, you found your rate. So now you have this linear equation that this is your new x value that you want to plug in. So we take 20 times 0.75. And if you plug that in, that's going to get you 20 times 0.75 is 15. So it's 15, 0.75 inches on your picture was 15 feet in real life. Okay, now that's definitely a longer way. It's a more mathematical way to do it. Just in case you kind of get to a point where that value isn't just a nice multiple of that value. And here's kind of the more mathematical way. But most likely, I'm just going to say, well, 0.75 is 3 of those. So then it's going to be 3 of those, which gets you your 15. Totally the same feel here. It's 5 of those. 5 quarters get you $1.25. So it's going to multiply that by 5. Your answer is going to be 25. Okay, so, but good news is we already have our equation. If we are doing it the longer way, or if it doesn't quite work out where it's a nice multiple of that, then we are just going to take our new x value here, 20 times 1.25. And when we multiply that out, that is going to get you 25. Okay, so that was a little bit of an introduction to direct variation.